Hi, my name's Nelson Elam. Today I'm going to talk to you about NFS Datastores with ActiveDR. So we're first going to configure ActiveDR with an NFS file system on FlashArray. Next, we're going to do some ActiveDR test failovers with an NFS Datastore. Then we'll do an actual DR failover with that same data store. And then we'll do a failback with that same data store. So going to the FlashArray first, we're going to create a pod that we'll use for ActiveDR and managing that NFS file system. We're going to move in our NFS file system, and here we're just going to search for the file system that we already have created, test NFS data store, and you can see right away that the policies get added to the pod when we move in the pertinent file system. A policy not shown here that's very useful for NFS data stores on FlashArray is the AutoDir policy that lets the host manage the directories for that file system on the array itself. So we're going to create a replica link here as well. We're going to connect it to our existing FlashArray x50-2. And we're going to create a pod on that site. We're just going to give it a -dr suffix so we can differentiate it from other pods. And now we'll see on both FlashArrays that ActiveDR replication is currently baselining. Skipping forward a little bit here, we're going to actually see that it's now replicating on both sides. But first, we're going to go into the file system and show you what's in here on the source side. So we've got some load VMs that we'll be using for our failover situations and failback situations. And you can see that on vCenter, those are present as well. And that directory structure was created by those ESXi hosts on that source array. On the target array, we can actually see this looks very similar to the source, except we're missing a policy here for export. So on the source side, we actually have the export policy, but that export policy did not get replicated over. So we're going to go ahead and create an export policy on the DR site, and we're going to do that so we can do some failover testing and failover replication in general. So we're going to create an export policy here. Let's give it a descriptive name. We're going to attach it to our DR pod on our target again. And we're going to disable user mapping. After that's been created, we'll need to actually create a rule for that so that our ESXi host can attach to this. We're going to do no root squash and read write as a rule. And now that that rule has been added, we are going to be ready for our test failover and failover scenario that we're going to run here in a second. And you can see that that policy was attached to our pod. We're going to actually run an ActiveDR test failover. To run an ActiveDR test failover, the source pod is promoted. The target pod will need to be promoted. We're then going to mount that target's NFS export on vSphere and register and power on a test VM. And then we're going to validate the health of that test VM. First, come to the FlashArray GUI, and we're going to see that on the target array, the pod is demoted. We're just going to promote that target pod. And then using the vSphere plugin, we're going to mount that NFS data store in vSphere. We picked the target FlashArray, and because we had created an export for this pod, we can reuse the existing file system, and we didn't have to create anything there. Now we have our data store here. I'm just going to go ahead and rename it to something a little more descriptive. So I'm going to give it a name that indicates that it's running on the target array, which is called x50-2 in our case here. And this will help with VM names if they're similar on the two different data stores. And in our case, they will be identical from X50-1 to X50-2 because that's what ActiveDR replicated over. So browsing the data store, we're going to find our VMX file here for NFS load VM01. We're going to select that and register the VM based on that. Just going to put it in the default location in my vSphere instance here on our cluster, and click Finish. We can see that the VM gets registered, and we have our production VM running on X50-1, and our DR VM, our test VM, is not currently running. So we'll just power that on. And when powering on a VM that was moved or copied, vSphere will ask what action was taken to bring that VM into the vSphere environment. This is going to depend on the needs of your environment, but generally copied is the safer option. And there's our prod VM, there's our DR VM. We're going to open up the console for the DR VM, just log in, and in your environment, you will do whatever testing is necessary for the application or the VM itself to validate the health of it and that everything replicated over is expected. And after you've done that, to clean up, you just shut down the VM on the target, and you're going to then unregister it, remove it from inventory, and unmount the NFS data store from the host that it was previously mounted to. The reason that this is necessary is when you're demoting a pod, as we are now in the FlashArray GUI, it marks it as read-only, and vSphere, when transitioning from read-only to read-write, needs to have the objects cleaned up. So next, we're going to do an ActiveDR failover. The source array, in this case, failed. We're going to promote the target array. We're going to mount the NFS export from the target array to vSphere. We're going to register and power on our production VMs on the target side. We're going to validate the health of those VMs. And we're going, once the source array comes back online, we're going to demote it and clean up those objects. So first you'll see that the FlashArray X50-1 is inaccessible. X50-2 reports that pod is unhealthy. We're going to promote it, and we're not going to have to do any quiescing because it's not able to reach the source pod. So now that that's been promoted, the same as the test failover, we're going to come in here to vSphere, and we're going to create a new data store using our existing NFS mount, the same way we did with test failover. Select our array, and you can see the plugins also reporting issues talking to X50-1. We're going to use that existing NFS data store export. Once that's been mounted, we're going to come in and actually rename it so that we have a useful name that's easier to differentiate between our two flash arrays, because their mounts are consistent on here. Now we're going to register our VMs. So in this circumstance, we're just going to register the one to show you what that looks like. Same as the test failover again. Put it on our DR cluster, then hit finish. Now that it's been powered on and we've given vSphere the information it needs about this VM that it was copied, we're going to validate the health there. And knowing what we're going to do later, which is a failback from X50-2 to X50-1 on this VM after we've logged in, I'm going to create a text file that has some good info in here for us about this file was created while this VM was on X50-2. So I'm just going to name that file X50-2 promotion test and populate it with some text. And we'll open this file later after we failed back. This text file will show us that our quiesce operation, forcing data from X50-2 back to X50-1, was successful. And X50-1 is now what we're going to refer to that as the original source, and we're going to refer to X50-2 as the original target, because it can get a little confusing with failovers. Now that we've created that file, X50-1 is going to come back and be healthy. So we're going to log into X50-1. On X50-1, we're going to look at the pod and ActiveDR and check that the direction of replication is what we expect, which it is. So we're going to go back to vSphere. So we're going to unregister these VM objects from here. We're going to remove them from inventory. And then we're going to unmount that NFS data store, the original source. We're doing this because we're going to demote the pod on the original source, X50-1. When we demote it, we are going to skip QSing because we don't want X50-1 to try to push any changes to X50-2. So skipping QSing is important here. And now we can see the direction of replication is correct, that X50-2 is replicating its changes to X50-1. Now we're going to do our ActiveDR Failback. So first, we're going to power off the VM running on the original target. Then we're going to unmount that NFS data store from the original target. Now that we've cleaned up the objects, we're going to demote the original target. We're going to promote the original source. And finally, we'll mount the original source NFS data store, power on those VMs and that VM and check it out. We're first going to go back to our vSphere interface, vSphere UI. We're going to power off that VM. And in this case, I'm just going to do that gracefully. So I'm going to tell it to shut down the guest OS. Once that's been shut down, we can remove it from inventory and clean up the data store object here by unmounting it from vSphere. Once that's been cleaned up from our cluster and vSphere, we're going to go to our original target and demote and quiesce the changes that have been on these VMs during this time where the original target was promoted and the original source was demoted. Right now, they're both demoted and those changes have been quiesced. So on the original source, we're going to promote the pod, using those changes that we just synced from X50-2, the original target. So from a promotion-demotion state, we're back in the original state now. We're going to go back to vSphere, use our vSphere plugin to mount an existing NFS data store from X50-1. And after that data store has been created, we're actually going to go in and rename it, just give it a more useful name, in this case, just by adding X50-1 at the end of it, so that we know where this data store lives. Another good way to do this is within the vSphere plugin. If you've installed the vSphere plugin on the Summary tab in the vSphere UI, you'll get these very helpful details about where this data store lives, what array it's on, mount points, those sorts of things. Now, I'm going to go to my VM and register the VMX file. I'm going to organize it, put it in a folder that's useful, and on our cluster. And now I'm going to move it into a resource group and power it on. When powering it on, again, this is going to depend on the needs of your environment. For the purposes of this video, I'm selecting copied it, but depending on what you're doing and what you need in your environment, move might make more sense. After it's been powered on, I'm going to log into it, and if you remember that text file that we created, populated some text into on the desktop, I'm just going to show that that data is still there. It was all replicated over. Thanks for watching. I hope you found this useful. Please check out our VMware platform guide if you have any further questions. Have a great day.